Hello everybody, this is Mr. Molikash again. This is our week 2 video for Math 172 online with Johnston Community College. If you happen to see this video and you're not in my class this semester and you have a question about what you see, feel free to shoot me an email. Alright, so in this week what we're dealing with is the unit circle. The unit circle, wonderful thing. It's kind of the Bible of trigonometry. So what I'm going to do is I'm going to show you how to kind of remember the unit circle and not have to look it up or like struggle with thinking about values in it. So the first thing that we're going to do is this week we're just going to look at the first quadrant, at least in this video. Alright, so the first quadrant of the circle looks like this, and the angles go like this. Okay, so you have 0 degrees here and you have 90 degrees up here. Okay, half of 90 of course is 45, and then there's a third of the way and then 2/3 of the way, so 1/3 of 90 is 30 degrees and 2/3 is 60 degrees. Okay, so those are the angles. For the radian measures, what you do is you have pi in all of these. So pi, 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 pi. I don't know about you, but I like pi. The only one that doesn't have pi is 0 degrees, and 0 degrees is 0 radians. I suppose you could say it's 0 pi, but the magic numbers for these are 6, 4, 3, 2. And to convert these between radians and degrees, go back to last week's video and remember how to do that. Okay, so radians is the degrees, as pi is the 180, and you can cross multiply and figure those out. Okay, then there's coordinates. This point has coordinates, and I'll erase the degrees for now so I have room for them, but this point has coordinates on the circle. So does this one, so does this. These are different coordinate ordered pairs. Okay, so this one's got ordered pair, this one's got an ordered pair. They all got ordered pairs, and this one also does. Okay, so since this is the unit circle, the radius is 1 unit. So here we go to the right 1 and up 0. Obviously this one will be 0, 1. Okay, so what you do for the rest of these, you start with 0, you end with 1, right? So there's got to be some numbers between 0 and 1 that get you from the bottom to the top. Well, here's the first one. The first one is 1/2. This is halfway up the y-axis. Okay, then what you have to realize is that the bottom of these fractions are all 2. So this is 0 over 2. This is 1 over 2. This is kind of 2 over 2, and this is kind of 3 over 2. And this is kind of 4 over 2. And when I say kind of, what you have to do is you have to square root the top. So this is the square root of 1 is still 1, but here you'd have the square root of 2, here you'd have the square root of 3, and the square root of 4. The square root of 4 is 2, and 2 divided by 2 is 1, and we thought that was 1, so we were right about that. The square root of 0 over 2 is 0. Alright, so these are the sines of each angle. So for example, the sine of pi over 6 is 1/2. Okay, this should be automatic for you. Like if Alex says, what's the sine of 7 pi over 6, you should know it's negative 1/2. You should, just by knowing the unit circle. So good trigonometry students know the unit circle. It is so important because so much of the rest of this class is going to depend on this. So if you don't study anything else this week, I hope you've been looking at the unit circle and you're familiar with it. Alright, now the other numbers are the cosines, and notice that the 0 is up here and the 1 is down here. So you just take the numbers and go backwards. So this would be 1/2, this would be square root 2 over 2, and this would be square root 3 over 2, and this is square root 4 over 2. So all the other numbers go backwards. And so for example, the cosine of pi over 2 is 0. The first number is the cosine, and the second number is the sine. That's really easy to remember if you think about x coming before y is in alphabetical order, and cosine before sine, it's also in alphabetical order. So just kind of keep everything in alphabetical order. Now, these angles aren't the only angles on the circle, but they're special angles, 30, 45, 60, and 90. There's a 78 degree angle on here too, and it has a cosine and sine, but we would use our calculator to find that out. Also, when using your calculator, make sure that you understand whether you should be in degree mode or radian mode. You might get a wrong answer and not realize why. So, for example, if you want the cosine of 62 degrees, you need to make sure your calculator is in degree mode. If you want the cosine of 7 pi over 5 radians, then you better be in radian mode in your calculator. So that's super important that if you're using your scientific calculator or Desmos or whatever, that you can change the radians or degrees depending on what's going on. Okay. So sine and cosine are functions. They are functions, and they have graphs that pass the vertical line test. So we'll talk more about this as the course progresses, but the graph of y equals sine x for all the values on this circle, if the x-axis is the angle and the y-axis is the sine of the angle, and we call this angle x. So it's a little weird, but don't think of x as being the x-coordinate on the circle. Think of x as being the angle going around the circle. All right, so the sine of 0 is 0. The sine of 2 pi is also 0. The sine of 1 pi is also 0. So those are all y-coordinates on the circle. And what happens is between 0 and pi, the sign is positive, and between pi and 2 pi, the sign is negative. So the graph kind of looks like this. And it repeats every time you go around the circle. So if you go backwards around the circle, you have the same graph. If you keep going past 2 pi, this continues on and on forever and ever and ever. The cosine graph looks a lot like that, but that graph is kind of shifted to the left a little bit. So the cosine of 2 pi is 1, the cosine of 0 is 1, the cosine of pi is negative 1. So that's kind of what happens. First quadrant, second quadrant, third quadrant, fourth quadrant. And again, this graph repeats over and over and over again forever in both directions. So it's a little bit about what's going on. Now, I will say that the sine graph is an odd function. From Math 171, you remember if we call this f of x, an odd function is one where f of x is the opposite of f of x is f of the opposite of x. This kind of looks confusing, but here's what I mean, If you pick any x value and find its y value, and then pick the opposite of x, you're going to get the opposite y. So when your x's are opposites, your y's are opposites. So whatever goes up must come down, kind of thing. That's an odd function. With even functions, the characteristic that you get from your Math 171 class is that f of negative x and f of positive x are exactly the same. They're not opposites. So you pick an x value, you find the y. You pick the opposite x value, you get the same y instead of the opposite y. Your hands do the same thing. So if your right hand goes down, your left hand goes down. If your right hand goes up, your left hand goes up. So these have symmetry over the y-axis. They're called even functions, and the odd functions have what's called origin symmetry. So across the origin, you're going different directions. So that's the even and odd properties of the trig function. Last thing we're going to look at today is the using the Pythagorean theorem to find out sine and cosine. So let's say, for example, hold on, I'm trying to navigate through here. Let's say that we're in section 4.3, and you have this triangle, and let's say that this is theta. So this is an adjacent side, this is an opposite side the opposite being all the way across from the vertex. The only side that can't touch that vertex is the opposite side. This other one's called the hypotenuse. It's the longest side. All right, so you might remember this from a previous math class. Some old hippie caught another hippie tripping over alligators, or tripping on acid, or some old hippie caught, wait a minute, some old horse caught another horse taking oats away. And I've heard all kinds of ones, but what this basically means is the sine, cosine, and tangent are defined by these letters. Okay, sine is the opposite divided by the hypotenuse. So the ratio of these two sides, this number divided by this number, would be the sine of that angle. Okay, adjacent divided by hypotenuse is cosine, so this divided by this, and then opposite over adjacent. Okay, so that's what's going on. And if you want to know, like, let's say that you know the sine of theta is 1/4. What's the cosine of theta? Well, what you could do is you could put, 1 as the opposite, right, and 4 as the hypotenuse, and then we could figure out, well, I don't know how long this side is, so I'm going to call it A, right? So I would do a squared plus b squared equals c squared. What's that called? What am I using? The Pythagorean theorem. Very good. So yeah, what this leads to is a squared plus 1 equals 16, and a squared is 15, and a would be the square root of 15. So because I now know the length of that side, I know the cosine of the angle, right? The cosine is the adjacent side, which is now square root 15, divided by the hypotenuse. And if you needed it, you could also get the tangent, which is the opposite over the adjacent. Okay? And Alex might tell you to rationalize that and get square root 15 over 15, but I think you can write it like this in Alex and be fine. All right, so that's just kind of a brief overview of what you would see in this week. Oh, one more thing that I forgot to mention, sorry, and that is the reciprocal functions. So secant, cosecant, and cotangent. If you've seen those and you've been wondering what the heck are those things, secant is the reciprocal of cosine. Cosecant is the reciprocal of sine, and cotangent the reciprocal of tangent. All right, so in a triangle, instead of adjacent over hypotenuse, this would be hypotenuse over adjacent. Instead of opposite over hypotenuse, this would be hypotenuse over opposite. And then this, instead of opposite over adjacent, this would be adjacent over opposite. Okay, so if you needed to get these functions from a triangle, that's kind of what's going on. Okay, so yeah, again, send me an email if you need some help. I'm definitely here to help. Every one of you is probably at a different place in your knowledge. You may be taking a class like this at high school. It may have been 10 years since you've taken a class that has any of this stuff in it. So, I really would like to hear from you if you need help, and just kind of remember that you are not alone. So keep working hard, be committed, stay in the course every day. Don't fall behind, and just remember, I'm here to help. Have a great week.